Hello. Today we are going to discuss Markov chain. Markov chain is a very important mathematical tool which is used to find the probability of one event. So the event which is dependent upon the immediate previous event. So this is a very easy and successful a tool to find the probability of, happening any event. So before going to discuss, we will discuss its history. So there was two mathematicians in Russia. So one was Pavel uh, Nekrasov, and Nekrasov was a religious mathematician, and he used to believe that the mathematics can be used to describe the free will. Free will, when there is uh, events are independent, they have no any dependent upon each other. So on the other hand, that Andrei Markov was atheist, and he was saying that mathematics had nothing to do with the free will. So in mathematics, the probability of flipping of coin, either you can have a head and a tail. So suppose we have 100 time flip, 100 flips. So maybe that you might have a 549 time head and a 451 time tail. Unless if you have another set of the flips, you might have 450 time, 55 time tail, and the rest is the head. But if you have a large number of flips, if you have a large number of the flips, you will see that it will be the probability of having a head and tail will be 50-50. So number of flips, if it become very large, the probability of 50-50 will be constant. So outcome will be closer to the expected value. This is exactly the same, which is Jacob Bernali in 1713 have discussed this one before. So if the events are independent, like a flips, so law of large number holds. So what about this one? When event it does not influence the other one. So that we will see this one. So probability to observe the law of large number. So that means if it's a law of large number is being observed, the probability of this one, then either the events are independent. This one discussed before. So when the events are independent, then probability of having 50-50 of law of large numbers observed is observed. So that mean that the event should be independent. What about dependent? So law of large number event must be independent. So now we will see that dependent events. So dependent events like this one, so marriages where the people have to decide and they are dependent each other to the different aspects. A couple with the children living together with the first marriage. So this is also dependent to husband and wife, and social crime that depend upon how is the people are behaving in a society, and birth rate also depend upon the parents their decision. So is the same pattern of convergence observed in this one? So yes, it is also have the same uh, obey the law of large number. So like this one, the first marriage in UK is the same every year. It is the same, which is a 20,000 couple going to marry every year. Similarly, number of family with the number of couples with the children, 80% living together. So this is also the same in year from 1996 to 2020 and going on. So that means the law of large number is being observed even in the dependent events. So if large numbers, if it is independent, flipping of coin, or if dependent, which marriages also converges. So in these both ways, the law of large number is being held. That means the law of large number must be followed. So that means free will can be measured scientifically. So probability will depend on event. So Markov used this one, if it is right, that one event clearly depend upon what comes before. So what comes before? So idea that he used text messages. In text messages, this one TH, then you can use E, then to make it a full word, or THEN, make it full word. So the after THE the word, it depends upon the sequence of the previous one. So next letter, either it is vowel or consonant. Markov used the prominent Russian poem. So this one, so uh, Eugene Ogin by Alexander Pushkin. So that has, if he omitted all the spaces and commas and full stops, and then it was the 20,000 letters in the series. So 20,000 letters in a one word. So like in one word. So one long string of characters. So all the poems. So so the appearance of the consonant and vowels. So consonants, so what was 57%, and vowels was 53%. So then overlapping pairs. So overlapping pairs like going home. If you have this one, so if it's this one GO and this one consonant and vowel, this is vowel vowel, this is consonant vowel, this one. So is he has used a couple and linked this one. So go, this one first word, first two letters. So go, so is a combination of a consonant and vowel. So CV, then OI. So this one OI, say vowel and vowel, VV. Then NG, this one. So NG, it is consonant and consonant. CC. So there are only four combinations. So vowel, vowel, consonant, consonant, vowel, consonant, consonant, vowel. If the letters are independent, then the probability of a vowel, vowel is vowel is 53%, which is this one. So vowel, vowel, this is 53, 53, which is 18%. But when Markov calculated the vowel, vowel pairs, and he found that only 6% is the time they appear the vowel vowel. So like in this one, this is vowel vowel. So how many time? It should be, if they are independent, that's 18%, but they come lesser than this one, which is 6%. 6%. Similarly, vowel vowel should be 18%, but it actually happening 6%. Consonant consonant should have happened in 32%, but they are appearing in 19%. Vowel consonant should be 25%, but they are happening in 37.5%. Consonant vowel 25%, but actually 37.5%. So the difference in expected to actual mean the letter appears are dependent. So these are dependent on each other. So consonant and vowel, which should be 25%, this one CV should be 25%. But if they are independent, but if they are dependent, they are different. This 37%. So letter appearance is a dependent, and then uh, if they are dependent, then they should follow the. If they are independent, dependent, they are not dependent. But if they are independent, then they should follow the large number. To prove this one, Markov created a machine of two states. So the two-state machine is like this one. So V vowel, vowel to vowel, and vowel to consonant, and consonant to consonant, and uh, consonant to vowel. So this one. So this is C to V. This is C to C. So in this one, V to V, so the probability of 6%, which is actual, divided by 43, which should, if it is they are uh, uh, independent, which is 13%. And this one, it is because the next letter definitely is some letter. So that is 1 minus this one, which is 87%. Then this one, CC, CC, it is equal to 1 minus 87% because 87 is this one. So 87 into 100% to this one, which is 33%. And then this one, if there is one letter, then it should be 1 minus 33%, which is 67%. So these, if they are dependent, then these are the transition probabilities uh, of the machine which Markov have uh, uh, made this one. So it should be like this one. So the probability of the transition, if 13%, if it is above and below 87%, so we have a consonant. So this one, if it is 13 to 87%, then we have, uh, if it is below 13%, then vowel. If it is in between 13 and 87%, then is a next letter is a consonant. So next letter is consonant. Below we will be vowel. So another letter, if it is between 67%. So this one, if it is 67%, so 67% vowel, and this one is below is a constant. So if it is above, so it is a vowel, is a below is a consonant. So from this one, so vowel start from how vowel 100%, and then it is a constant 78%. Then vowel it is 21%, and then he used this one, and this one it is different vowel instead of a whole 20,000 letter. So he made a vowel constant. So the probability jumps from the 100%, 87%, 21%, like this one. So this one, so like in the first case, which was we used this one first, like this one, it is moving up and down initially. So first, the ratio of vowel constant jump all over the places, and 100%, and then 78%, then 21%, then 78%, and then it converges to steady value, which is 43% vowel and 57% consonant. So from this one finally converges to the steady state value, 43% vowel and 57% consonant. This proves the dependent system of letter converges. So that follows also the law of the convergence. So the both, in dependent and also in independent events, the probability converges. So law of number is followed. So in a social statistics where crime, marriages, and birth rate convergence is happening, so did not prove that underlying decisions are independent. So they are dependent. So they also follow that law of large number. So the probability of dependent event, Markov. So real world, everything is dependent upon something. So the dependent events are dependent or independent, both follow the large number, law of large number. So real world, in a real world, weather, it depends upon the condition of today. So tomorrow we will predict it. So the spread of disease depend upon how many people are infected today, so that we can predict it tomorrow. Behavior of nuclear reactor, nuclear particle in a nucleus depend upon the behavior of the particles around them. So this is very important, and we will discuss tomorrow. So this is the very important mathematical model which is used to predict the condition, future condition based on today or present condition.